Hi students, in before videos we discussed so many problems based on pH calculations in ionic equilibrium. Now we will discuss some important concepts, salts, types of salts and salt hydrolysis. What is the salt? What is a salt? The substance which does not give any H plus or OH minus in its first ionization. The salt does not give, the compound does not give any H plus or OH minus. That is called as salt. The substance which does not give any H plus or OH minus in its first ionization. That is called as salt. So here salt, for example, NaHCO3. So in first ionization, Na plus and HCO3 minus. It does not give any H plus and OH minus in first ionization. For example, NaCl, Na plus and Cl minus. This is the first ionization, does not give any H plus and OH minus. This type of compounds are called as salts. The type of compounds are called as salts. So next, classification of salts by nature of classification of salts based on nature of the salts divided into three types. How many types? Three types. Neutral salts are simple salts and acidic salts and basic salts. Classification of salts based on nature of the salt divided into three types: neutral salts, acidic salts, basic salts. So what are neutral salts, what are acidic salts, what are basic salts? Neutral salt means, so for example, NaCl convert to Na plus and Cl minus. The salt does not give any H plus or OH minus in any ionizations. First ionization or second ionization or third ionization does not give any H plus and OH minus ions. The type of salts are called as neutral salt. The type of salts are called as neutral salts. For example, K2SO4. So that is dissociated into K plus and SO4 minus 2. So your first ionization or second ionization, whatever it may be ionization, so does not give any H plus and OH minus. The type of salts are called as neutral salts. The type of salts are called as neutral salts. Next, acidic salts. The salt which give H plus ions other than first ionization. In first ionization does not give any H plus ions, that is the salt. So in second or third ionizations other than first ionization, the salt which give H plus ions, the type of salts are called as acidic salts. The type of salts are called as acidic salt. For example, so here H2CO3 is a dibasic acid. H2CO3 is a dibasic acid that is react with NaOH to form NaHCO3. So again that is react with NaOH to form Na2CO3. Na2CO3. This is does not react with NaOH. So this is the neutral salt. Na2CO3 is a neutral salt. NaHCO3 react with base. So this is the acidic salt. So first ionization that gives Na plus and HCO3 minus, and HCO3 further ionization to give H plus and CO3 minus 2. In second ionization other than first ionization, this gives H plus ions. That's why this is the acidic salt. So that's why this is react with NaOH to form Na2CO3. So Na2CO3 does not react with base. That's why this is the neutral salt, not a acidic salt. Here H2CO3 is a dibasic acid to form two types of salts. One is NaHCO3, another one is Na2CO3. This is the neutral salt, this is the acidic salt. So, for example, take a NaHCO3 solution plus NaOH solution. These two are exist or not. So after some time, so they take the equal amounts, that is react to form Na2CO3. Na2CO3. So these two are react. So these two solution cannot be exist. Why? Because that solution, the two are can be react. That solution cannot be exist. So after some time, NaOH not there, NaCO3 not there. After some time, what is there in beaker? Na2CO3 solution is there. So these two solutions cannot exist. Why? Because it have acidic nature. It is a base. Base and acid react to form salt. So this type of salts are called as acidic salts. Next, basic salts. So basic salts. So for example, CaOH twice is a base, that is react with HCl to form CaOH and again react with HCl to form CaCl2 plus water. So CaCl2 does not react with any HCl, so this is the neutral salt. So this is the react with HCl, that means this is the basic salt. So in first ionization, there does not give any H plus and OH minus, that's why this is the salt. This is the salt. That salt is a neutral or acidic or basic. So second ionization that gives OH minus, that's why this is the basic salt. Which salt? Basic salt. So this is a salt. How it is said that is a salt? In first ionization that does not give any H plus and OH minus, that's why that is the salt. In second ionization that gives OH minus, that's why this is the basic salt. Here acidity is 2 to form two salts. That is the first is the salt is a basic salt. Next last salt is a neutral salt. So this type of salts are called as neutral salts. So that are depending on basicity. For example, H3PO4 is a tribasic acid. So it can form three types of salts. NaH2PO4 and next again react with NaOH to form Na2HPO4 and next again react with NaOH to form Na3PO4. This is does not react with base. So these two solutions are exist or not? These two solutions are exist. Why? Because the two solutions cannot react. This is the now neutral salt. This is the base. But these two solutions cannot exist. Why? Because it have acidic nature. It is base and acid to react to form. After some time in this beaker, what is there? Na3PO4 is there. So this is the acidic salt. And these two solutions also does not exist. Why? Because this is the acidic salt and this is the base. These two are react to form NaHCO4 and further react to form Na3PO4. Finally to form Na3PO4. So this is the acidic salt. This is the neutral salt, normal salt or neutral salt. This is the acid. This does not. In first ionization, this is give easily H plus ions. So this is not a salt. How it is identified? This is the acid. So first ionization H plus C give, that is the acid. Second ionization and H plus give, that is the acidic salt. So first ionization H plus releases, that is the acid. In first ionization OH minus is released, that is the base. So first ionization does not give any H plus or OH minus, that is the salt. Salts are divided into three types: neutral salts, acidic salts, basic salts. That is depending on acidity and basicity. For example, HCl is a monobasic acid. It forms only one salt, that is the neutral salt. Monobasic salts form only one type of salts, that are neutral salts. For example, dibasic acids to form two types of salts, that is first salt is acidic salt and next salt is a neutral salt. And tribasic acids form three types of salts. First salt and second salts are acidic salts and third salt is a neutral salt. So tetrabasic acids form four salts. First three salts are acidic salt, last salt is a neutral salt. So how to identify this is the acidic salt or basic salt? This is the explanation. This is a very, very important explanation. So don't miss it. So next, classification of salts. Based on strength, that are divided into four types. So salt of strong acid and strong base, salt of strong acid and weak base, salt of strong base and weak acid, and salt of weak acid and weak base. These are four types based on strength of the acids and bases. So what are that? So the salt of, for example, first salt of strong acid and strong base. How to identify that salt prepared from strong acid and strong base? For example, this is the NaCl. So this is the normal salt or neutral salt. This is prepared from strong acid and strong base. How it is identified? So some strong acids and strong bases are there. HClO4 is a strong base acid, Hi, HBr and H2SO4, HCl, HNO3. These are very strong acids, and strong bases are there. NaOH, KOH, RbOH, CSOH, and second group bases CaOH twice, and SROH twice, and BaOH twice. These are strong bases when compared to remaining all bases. These 6 bases are very strong bases. 7 bases. These 6 acids are very strong acids. The salt prepared from strong base, here NaOH is there, and HCl. This is the strong acid, this is the strong base. This salt NaCl is prepared from strong acid and strong base neutralization. That's why this salt is called as strong acid and strong base. So the ions are very weak. The ions came from strong acid and strong base. The ions are very weak. That means, so NaOH is a strong base to produce Na plus OH minus. So this is the very weak conjugate acid. This is a very weak conjugate acid. For example, HCl is a very strong acid, H plus and Cl minus. Here Cl minus is a weak conjugate base. Weak conjugate base. The weak ions, which are weak ions, which are strong ions. How to identify? So that is the very, very easy. So you take the another salt, second salts. The salt of strong acid and weak base. The salt of strong acid and weak base. So for example, the salt prepared from strong acid and weak base. Strong acid means this strong acid. Weak base means this is not a the base not coming from these bases. So for example, NH4Cl. So this is prepared from NH4OH plus HCl. So HCl is a strong acid. So NH4OH is a weak base. Why? Because that is not there in that. So these are very strong bases. Remaining all bases are weak bases. So the salt prepared from strong acid and weak base. Strong acid and weak base. So next. So this is prepared from strong acid and weak base. So NH4 plus and Cl minus ions are there. It is coming from strong acid. That's why this is the weak ion. Weak cation or anion? Weak anion. So next, this is coming from weak base. That's why this is the strong cation. So this is the strong cation. This is the weak anion. So next, very very important salt. The salt of strong base and weak acid. Strong base plus weak acid. So for example, CH3COONA, CH3COONA, and next Na2S and KCN. These all are strong base and weak acids. So this salt is prepared from acetic acid plus NaOH. Here NaOH is a strong base or not? The NaOH present in these bases. That's why this is the strong base. So this is the weak acid. Why? Because this is not present in this list. Other than these acids, remaining all acids are weak acids. So this salt is prepared from weak acid and strong base. That's why the salt of weak acid and strong base. So very very important. So these ions, what are ions are there? Acetate ion and here OH minus or Na plus. So this is came from strong base. This is came from weak acid. So the anion came from weak acid. That's why that is a strong anion. Strong anion. So cation came from strong base. That's why this is the weak cation. So this which are strong anions, which are weak anions, that is very very important in salt hydrolysis. That concept is required to explanation of salt hydrolysis. So next important salt of weak acid and weak base. Salt of weak acid and weak base. Salt of weak acid and weak base. Weak acid plus weak base. That salt not prepared from these acids and these bases, that is called as the salt of weak acid and weak base. For example, ammonium acetate. This cation not prepared from this acid, this cation not from these bases. So this is prepared from acetic acid and NH4OH. Both are weak. Acetic acid is a weak, NH4OH also weak. Weak acid and weak bases combination to form this salt. For example, ammonium sulfide. So this is prepared from NH4OH plus H2S. This is the weak acid. This is the weak base. So here which ions are there in this salt? Which ions are there? NH4 plus S minus 2. NH4 plus S minus 2. This is the strong cation. This is a strong anion. Why? Because the anion came from weak acid. So this cation also came from weak base. The ions came from weak acid and weak base. That ions are very strong. The ions which came from strong acid and strong base, that ions are very weak. Based on strength of the acids, salts are divided into how many types? 4 types. Salt of strong acid and strong base, salt of strong acid and weak base, salt of strong base and weak acid, salt of weak acid and weak base. These are classification of salt based on strength of the acids. Nature of the salts are divided into 3 types: neutral salt, acidic salt and basic salts. So next go to salt hydrolysis. That is the very important topic in ionic equilibrium. So don't miss it. Once listen. So what is the next topic? Salt hydrolysis. This is the very important topic in ionic equilibrium. So that is the very useful for you. So what is the salt hydrolysis? In salt, cation or anion or both react with water. Cation or anion or both react with water to produce H plus or OH minus, or both H plus and OH minus produced in water. That type of hydrolysis, that is called as salt hydrolysis. That is called as salt hydrolysis. Salt hydrolysis means in salt dissolve in water, the cation or anion both react with water to produce H plus or OH minus, or both H plus and OH minus. That is called as salt hydrolysis. So salt hydrolysis means both cation or anion or individual cation or anion react with water to produce H plus or OH minus, both ions produced in water. That is called as salt hydrolysis. So based on salt hydrolysis, here 4 types are there. Salts are divided into 4 types. Based on salt hydrolysis, salts are divided into 4 types. So I will explain 2 types of the salt hydrolysis: cationic hydrolysis and anionic hydrolysis. What is cationic hydrolysis? What is cationic hydrolysis? For example, in salt, cation only react with water. Cation only react with water. That is called as cationic hydrolysis to produce H plus ion. To produce H plus ion. That is called as cationic hydrolysis. In cationic hydrolysis, the nature of the aqueous solution is acidic nature. Why? Because here acid H plus is released. So pH value is less than 7 at room temperature. Less than 7 at room temperature. So for example, anion react with water. So anionic hydrolysis to form Ha plus OH minus. Here base is OH minus is produced. The aqueous solution of the salt have basic nature. Which nature? Basic nature. So pH value greater than 7. pH value greater than 7. So some salts, both cation and anion react with water. That type of hydrolysis is called as both cationic and anionic hydrolysis. Some salts only cation react with water. Some salts only anion react with water. Some salts both cation and anion react with water. That type, this only cation react, that is the cationic hydrolysis. Only anion react, anionic hydrolysis. Both cation and anion react with water, that are called as both cationic and anionic hydrolysis. So cationic hydrolysis, that is the acidic nature. Anionic hydrolysis, that is the basic nature. Both cationic and anionic hydrolysis, that nature is depending on nature of the that acid or base present in the salt. The strength of the acid and base. The nature of the that salt hydrolysis depending on. So strength of the acid and base are depending on Ka and Kb values. Depending on Ka and Kb values. So now we explain hydrolysis of different 4 salts. So first salt, what is the first salt? The salt of strong acid and strong base. So first salt is salt of strong acid and strong base. So for example, NaCl. So how it is here? This is the strong acid, strong base salt. Here already know that strong acids HClO4, Hi, HBr, H2SO4 and HCl and HNO3. These are very strong acids. And what are strong bases? What are strong bases? So NaOH, KOH, RbOH, CSOH, these are strong bases, first group bases, second group bases, and CaOH twice, SrOH twice, and BaOH twice. These are very strong bases. The salt prepared from strong acid and strong base. So this is dissolved in water. The salt is dissolved in water to produce which ions? So cations and anions. So Na plus and Cl minus produced in water. So the ions came from strong acid and strong bases that are very weak conjugate acid base ions. So that ions does not react with water. That ions does not react with water. That means that salt does not hydrolyze. That salt does not hydrolyze. So this type of salts does not hydrolyze. The nature of the solution. The nature of the solution is neutral. The nature of the solution is neutral. So that type of salt does not hydrolyze. What is the nature of the solution? Neutral. The pH value is 7 at room temperature. At 25 degrees, what is the pH of the solution? Neutral. So for example, what is the pH of 0.1 NaCl solution? NaCl solution. What is the pH? So this type of salt, pH value does not depending on nature of the salt and does not depending on concentration of the salt. This type of salts, pH value does not depending on nature of the salt and concentration. Here pH value is 7 at room temperature at 25 degrees. For example, pH of 1 NaCl solution is that is equal to also 7. So next pH of K2, so 1 K2SO4 so is a neutral salt. This does not react with water, so the salt does not hydrolyze. Which of the following salt does not hydrolyze? So the salt prepared from strong acid and strong base. Strong acids, these are strong acids, these are strong bases. The salt prepared from these acids and these bases, that salt does not react with water. So K2SO4 also does not hydrolyze with water, does not hydrolyze, that means does not react with water. This aqueous solution of this solution is a neutral nature. The pH value is 7 at room temperature. So the salt prepared from strong acid and strong base, that salt does not hydrolyze. Why? Because that ions are very weak. Why? Because came from strong acid and strong base. Here K plus, Na plus is very weak and Cl minus also very weak. Weak ions does not react with water. Weak ions does not react with water. That's why this type of salt does not hydrolyze. What is the nature of that aqueous solution is neutral. The pH value is 7 at room temperature. pH value is 7 at room temperature. This type of salts, pH value does not depending on nature of the salt, that means KCl or NaCl, whatever it may be. That salt prepared from strong acid and strong base, that is a neutral, that solution is a neutral solution. pH value is 7. So this is the very very important classification. This type of salt does not hydrolyze. So for example, RbCl, aqueous solution, what is the nature? Neutral. Why? Because that salt does not hydrolyze. What is the pH of the solution? 7. For example, CSCl, the salt does not hydrolyze. Why? Because that is prepared from strong acid and strong base. That ions are very weak. That's why not react with water. That aqueous solution is a neutral, pH value is 7. So this concept is very important. So next go to